Hello and welcome back to the lab. I have gotten a lot of questions and requests for a lab video tour. So what I thought I'd do in this video is, one, I'd like to say thank you for everybody who's joined us and joined me in the lab and subscribed to the channel over the last 2 years. As of the recording of this video, this moment, there's 715 people subscribed to the channel. When I posted the first video, just repairing a joystick for a computer, and then that is actually a silent video because the audio in that video was so terrible that I couldn't even post it. The comments, the questions, have been overwhelmingly positive. The feedback has been amazing. For everybody who joined Patreon and the patrons of the channel, your guys' help in the decision-making process, and also as the sole sponsor of the channel, because my channel is, nothing in this channel is sponsored. I paid full price or market rate for secondary equipment. With everything that's been in the channel, there are 0 sponsors. Nobody's even reached out to me yet to sponsor anything. So it's just been putting the lab together and helping me make decisions, and also supporting the channel. It's been amazing, and I am so glad that everybody is here. And I'm also very thankful that I can assist in everybody else in getting their labs up and running and getting some things off the ground. So thank you all for being here. Towards the end of the video, I also want to talk about some future projects, and I'd also like to get some feedback from everybody out in YouTube and email and everything. Some of the stuff you guys would like me to cover. I'm getting a lot of requests for more 400 series content, more 7K content. That is on the way, I promise. I have a 7904A on the shelf that needs time on the bench, and I have a 485 waiting for the bench as well. I'm going to do, my plans are the 4-part series on the 485 and things like that. So there is more 7K and 400 series content on the way. And I'm also trying to push the lab in all areas: precision DC, high-speed RF, things like that. There's some high-speed projects that I have to do with calibrating the 284. That's going to need about a 6 gigahertz scope to do, probably. So we're getting into, the lab is definitely going to go into the esoteric for sure. So that's all coming. That's all in the works. And I also have some plans for upgrading the camera gear in the lab as well. I'd like to get, I was thinking, because I can't even monetize the channel on YouTube, so YouTube's not even giving me any money until I have 1,000 subscribers. Not a problem. I'm very thankful everybody's here, and I'm having a great time just working in the lab. But one of the things I'd like to do is I would like to upgrade the camera. This is an HD camera. I do need to upgrade the camera gear. I want to get more 4K. I'd like to record in 4K just so it can capture some more detail. And I would also like to get something with a changeable lens. The camera that I'm using currently right now is it's a Canon AX20. It's got a fixed lens, so I can't get as close as I want to some of the shots, things like that. So I am limited by the lens on the camera. But I would really like to do some close-in macro soldering, things like that, just giving some additional content. But I'm limited by the camera, so that is in the works too. I'm starting the research process as to what camera I should get, because I don't even know what I should get for that yet. So if anybody has any suggestions in that regard, please let me know. Definitely looking at cameras. Would like to keep it in the Canon world, only because I already have with my still camera, I already have some investment in Canon glass, and depending on what camera I get, the Canon glass, the lens, can be used in the entire line of Canon cameras. So if the real investment in camera gear is the glass. So if I'm gonna get glass, I'd like to stay in the Canon world, but that's the only limitation. Other than that, I don't know. I'd like 4K, 60 FPS 4K for the channel, and if you guys think I need to do something audio-wise, let me know as well. Currently, I'm using a Shure headband microphone. That's what the current microphone is. It's a wireless microphone, which is hooked in down here. You can actually see the display right there. That's what this cord is. It's running up to the side of the camera, XLR up here, so I can get audio to the camera, because I really, really don't want to use the microphone in this camera. It's way too noisy, especially with some of the environmentals that I have in the lab, because I have dust filtration, humidity. I do monitor the environmentals in the lab. For where I'm at, if the humidity dives too low, things start getting sparky, and static builds up, and one of the ways I manage that is making sure the relative humidity is between 40 and 60. Anything under 40, I start popping, just getting out of a chair. So got to bring it up. Way over that way, there's actually a wood-burning stove. We're underground, and it gets cold here in the wintertime. So there's a wood-burning stove that the humidifier has to fight. So having the space, I have a 2,000 square foot humidifier for this space, because that's what it takes to keep up with the wood-burning stove. So, but getting into the lab tour, this is the way the lab's been laid out for the last year, as I've been adding gear. Not much has moved around. Some stuff in the power supply stack right here has moved around. I'll do close-up shots here in a little bit. But, and I have done a little bit of the soldering stuff. This rack was put in early this year to hold some of the heavy gear. I wanted to get a 576 close to the bench. But then also this DSA, this rack is actually, I believe it's 18 inches deep. It's either 18 or 24. It is absolute. The DSA, the 602A, is just a monstrous piece of gear. It's 90 pounds. It is huge. So this hutch over top of the bench here, that was starting to bow a little bit, so I had to reinforce that and move some of the test gear around, because that's why the 5,000 frames are on the sides, because it was too much weight right in the middle, and there's no support right in the middle, so I had to move it around. I didn't want anything to collapse on the test equipment. The table itself is actually a home built. I couldn't find anything that I really wanted. And I wanted to be able to support some of the 7,000 frames, and just nothing was deep enough, wasn't working, so I ended up building the entire table. To give a size comparison, that is an entire 4 foot by 8 foot sheet of plywood. Actually, it's 2 3/4 inch 4 foot by 4 by 8 sheets of plywood, double stacked, epoxied, and screwed together to make that tabletop. So it's that gives you some of the dimensions of the lab, and also, while we're looking at it, some of the gear. All the electric in the lab was actually done by me. Check your local municipalities for if you're allowed to do your own electric. In my area, I am, as long as I get it inspected by the city. So everything was permitted, installed, and inspected. You'll notice in some of the shots there's this black triangle foam that's on the walls. That's a sound deadening foam. There's the sound treatment for the space where I record is 3 or 4 boxes of that stuff. Went up to the walls. I did it solid. You'll see it patchworks in a lot of people's videos. That's actually sound treatment for echo and things like that, so you don't have a lot of reverb that's picked up by the microphone. The lab cat might walk by. You might get... We'll see what happens. She's at least being vocal. It makes the space nice and quiet acoustically, even when I'm working. There's acoustic tiles in the drop ceiling, and then above that, above that, there's a Rockwool Safe and sound deadening material that's in the rafters. So there's a lot of soundproofing going on. That's why it's nice and quiet down here when I'm recording. So I didn't realize it until I actually did the sound treatment. It's real nice to work. Focus is a lot better and everything. So I'm enjoying it. This wall, since we're talking about structure of the lab itself, this wall, actually this is one lab of several, has 80 amps of electric in it. So I'm in North America, which means I'm on 110, 240 split phase. So it's 80 amps of 110. But for measurement's sake, I made sure that all of the test gear, so all 4 circuits, it's 4 20 amp circuits, all 4 circuits are on the same side of the panel. So they are, and the breakers are staggered. So everything here is on the same phase of power. Well, split phase. Everything is on the same side of the transformer. So not sure if that really matters to my measurements or not, but it seemed like something I should do since I was putting everything in anyway, and I have space in the breaker box. That's the way we engineered that. So I'm going to do a quick pan, wide shot, and then we'll get close up to... we'll start here, work our way around the lab this way, and then I'll show what's over here on the other side of the bench, which normally doesn't get shown in pictures. But we'll do a quick pan of the lab. And this is a wizard space. So, unlock this. All important coffee. And you can see this is actually behind me as I'm recording, and that is, oh, hey. Right, there's the lab cat. Wave to YouTube. And she wanders. Yeah, there's 2, so these are 2, on this side of the lab, there's 2 independent computers, and I'll talk about those here in a little bit. But I'll go back to the test gear, and we'll get started. Okay, starting at the top, we have this. I didn't realize it, but right here, I need to dress this cable up a little bit better. This green cable is the main network feed that feeds the lab. So that is, that's where I get it's a 1 gig link back to lab number 2. That's where I get my internet data and everything from, and hook the test gear up. All the test gear that has network cards is hooked up, and everything's IP'd, so we're working on data collection and things like that. This right here, this is a bit of cable storage on the back of a bookshelf. This is the bookshelf that holds the paper library. Given that I have so much in paper, or I have limited space, so what I'm trying to do is have as little paper as possible. So I have a tablet that actually stores the bulk of the technical library. There's some things that I just like paper in because I flip through it and back and forth and things like that. So some stuff I like paper. We have right here, this is the current limited portion of the Variac isolation transformer current limited power supply. There's 6 lamps in there. Each lamp is a 60 watt bulb. Each bulb will give me about a ½ an amp of current, so I can dial the current limit depending on what I'm working on. When I wanted to fire up one of those 576s, 2 lamps wasn't enough. So this will give me about, each lamp is a ½ an amp, and there's 6. And then there's the confidence switch right there, which bypasses all the lamps and just passes voltage through. And it's removable, so I can, it's just got a regular plug coming out of it, so I can dial it in. There's the Variac for the Variac current limited supply. Up here is, where's the pointer? There it is. Up here is the bench computer. This is just a small Dell workstation. I think it's a 9020. Core i7, 8 gigs of RAM. It runs into small, like 256 gig SSD. Its primary purpose is it plays music while I'm working on things, but it also allows me to look up data sheets in the lab, things like that. I have the monitor mounted vertically. You can just see the back side of the monitor here. Actually, we'll turn that way. So there's the back side of the monitor, and it's a 1080 monitor, but it's great for looking at data sheets on the lab, figuring out chips, things like that, looking at my parts inventory, seeing what I have. If I'm mentioning anything that anybody wants me to go in more detail to, let me know, and I will add it to the list of videos. As we go down, there's the small UPS that drives the bench computer, and then we have just a standard monitor that I use to troubleshoot PCs on and build PCs for people. So just a 24-inch. One of the reasons I keep this monitor around is it has VGA, DVI, DisplayPort, and HDMI on it. So it's even got composite on it. So it's just got every connection that I could possibly need in one monitor. It's big, it's clunky, it generates a lot of heat, but it works. Next up is magnification. This is one thing that I want to upgrade in the lab. This one's working fine for now. However, this is very old and it still runs a fluorescent lamp. It's not even LED. But I want to get this to a Mantis. So that is coming up on the shorter and shorter list of things to buy as things get smaller and smaller. I'm wanting to get something with magnification, so a Mantis is in the future. Okay, up here we have our first test block for amplifiers. Actually, technically I've done this the wrong way because I have the AA501A, an SG502, and an SG505. This is the non-balanced. This is the non-option 2. This is an option 1. However, I have that with the better distortion analyzer, so I should actually switch distortion analyzers to put the A with the option 1, but that's okay. Little pill bottle up here. It has some small cap adapter boards in it. A little bit of a butane torch. Coming down, we have this is a Tektronix power supply that rarely gets used. I still need to rebuild that one. I haven't rebuilt it yet, but it's in there for ventilation purposes. We have that's the differential amplifier. That's the AM502, and that I did a restore video on. And next to that, we did an SG504. I have not done the restore video on the restoration video on that yet. Everything's working on this SG502. The high range is not. So I have a sneaking suspicion the pin diodes are bad. That's why I haven't done anything there. Right here, that's the SG503 that I've restored. The TM501 that will be getting modified soon. That in part 2 of the TM501 video, which I'm waiting on parts for, that I'm going to do the 10 megahertz reference modification to this. Rotating just a little bit. That's the PG506. Some of the lab, actually part of the Cal lab for the bench, was that PG506, getting that thing up and running and calibrated. He was one of the reasons why I bought the DMM7510. Coming down, we have the first new scope that I ever bought. This is a Rigol. It started out life as a 1104Z Plus. Well, the Plus is they don't ship you the logic analyzer pins. So as soon as you buy the logic analyzer cable with all the grabber hooks, it becomes an MSO. So it has all the MSO capabilities, you just don't get the cord. Very nice 100 megahertz scope. This was what allowed me to bootstrap the lab up to get everything working. and push the calibrations faster and faster and faster and faster. So with this scope and a very careful order of operations, I was able to go from a 100 megahertz scope to being able to calibrate a 500 megahertz scope in the lab, and everything backfeeds to everything else. But this was, until I got a better one, this used to be frequency standard truth. It's not anymore, which I'll get into that here in a little bit. But I do not regret buying the 100 megahertz. Actually, I could have bought faster than that, and it would have been better for me. But 100 megahertz is where I got started, and the price was right. If you do go after one of these Rigol scopes, every once in a while they put them on sale, where the software package is free with the scope. If you're thinking about it and you can wait for that. It's like an $800 add-on value, and it's all the advanced triggering, it's the all the decoding, everything like that. I can go deeper if people want, but it's wait to get the free software upgrade with the scope. It doesn't upgrade the bandwidth of the scope, but it does add all the fancy triggering and features. The logic analyzer cable is this thing. So it just it plugs in the front, and that breaks out your 16-channel logic analyzer. I have had to use that on occasion, and it was real nice to have when I used it. Moving down, we have a Venerable 465B. This is the 465B that I restored and did the calibration on, and the 4 videos for the 465B. So that is 100% up and in spec. And it'll be on the bench until I do the 485. This will eventually get replaced with a 485, but I still have to do a calibration on that one and get that one up to speed. Moving down further, we have one of the rabbit holes that I have decided to fall down. This is the 47854. I really want to get this scope up and running, but I need to do a full calibration on it, which is part of why I've been designing that cal board for this. I'm just stuck waiting on parts. My limiting parts right now are the transistors that are on it. A couple of the ICs are back ordered, and the capacitors are back ordered. So like 80% of that board is back ordered, and all I'm getting is emails that are just pushing it further and further and further back. This guy works. However, it is out of cal and needs an adjustment. So I will be doing that. There will be a full calibration restoration on this on the channel once I get that board made and tested. I do have a test frame that got damaged in shipping. It's a complete scope. The back end got caved in, and all the boards are out of it right now because it worked for like 2 seconds, and then the readout board went, which is something wrong in the computer section, which is going to be interesting to troubleshoot and find. I do also have, hiding back here, yeah, you guys can see it just a little bit, I have the waveform keyboard hooked up to this, so I have the keyboard and I have the scope, so that is pretty good there. All right, going back up to the bench, back up top. As we go back up top, we have a Venerable IT28. I don't think this unit needs any introduction. It's a capacitor checker. I don't use the bridge in it very much anymore because I have a digital capacitor checker. However, I do the leakage, or I should say I did. I restored that unit, got it all back to rights, and I used to use that for some of my leakage testing on capacitors. I now have a much more sensitive unit for doing leakage testing now, so it's kind of redundant. However, it can still go to a higher volt until I get the 2470. It still goes to a higher voltage, so I'm keeping that around for a little bit and going from there. Moving down, we have a Keithley 2380, 120 volt, 60 amp electronic load. I was notified that the BK Precision has the exact same internals to it, and why did I spring for the Keithley? Just so happened that when I ended up getting it, the Keithley was cheaper than the BKs. So with everything that was going on, the Keithley ended up being a couple $100 under the BK. But both of them are exactly the same unit. They have exactly the same internals, at least that's what I've been told. But I needed something to put a load on. One of the things that people might have seen on the channel is I repair a lot of UPSs because I have a computer lab and a few other things as well. So the UPSs, I have to load test the batteries every once in a while, and it's kind of fiddly. So having a proper load where I can just hook up the batteries and test them is good. And also some of the UPSs that I have to fix, actually I just, before I'm shooting this video, I had to repair the one that was in my rack already because it's 72 volt battery. It's a 72 volt battery pack. Its 72 volt battery pack just died. The batteries are actually wavy. So they were in real bad shape. But I got that fixed. So moving slightly down, two of my daily drivers. Well, one of my daily drivers. The other one is my truth, or part of my lab truth. The DMM6510 is pretty much my daily driver. It's a 6.5 digit multimeter. It's fantastic. I use it in lots of my videos. Having the graphic and the speed capability of that meter is absolutely fantastic. You could, if you put it in graphing mode, you could actually see the voltage and current moving while you're doing an alignment that typically you would do on a VTVM. But and they're fast. The 1 meg sample per second. These two meters can be a 1 mega sample per second oscilloscope. Not for very long, but for quick capture at their rated accuracies. So now the accuracy degrades a little bit. To get the full accuracy out of this, the measurement takes a bit of time. It's 15 power line cycles with averaging of 10x. So you're at 150 power line cycles for a single measurement at its full accuracy. Warm-up time on these two meters is half an hour for this, hour and a half for this guy. But this is the 7510, so that is a 7.5 digit multimeter. I have been told, and it is probably true, that there will be a 38.5 digit Agilent in my future. That is probably true. However, I don't have that yet. But I am looking. I believe it's a 3458A. Don't quote me on that. So I do not plan on maintaining the calibration on this meter. It's not going to get sent off to Keithley. It's not going to. This one's just going to sit in the lab. I do plan on maintaining the calibration on the 7510. So I've already got the quote from Keithley. I'm going to send it off. So if you see it gone from the lab for a couple of videos, it's just headed back up to Keithley, and they're going to do the accuracy, or they're going to do the calibration, but I also asked them for the calibration with data. So we'll get offsets and everything for that meter as well. So when it's due up, it'll be gone for a couple of weeks, and then we will see how it goes. Moving down, we have the Venerable 7603. This is one of my daily driver scopes, along with the MSO 1104. 100 megahertz frame with the correct plugins. I have it with the 75 megahertz plugins because I get 50 microamps or 50 microvolts at its most sensitive setting. So that's the usual plug-in complement that I have on that scope. The plug-in complement on the 7854 can be kind of dynamic depending on what I'm doing. And my end goal is to have the 7904 on a cart. So if I need 500 megahertz, I can wheel it into the lab and then wheel it back out. Because I only have enough room, even though the bench is huge, I only have enough room for one 4-bay frame on the bench. The other thing that I like about the 7603 is, if I pull this off, this is a 3D printed light shield that you can make. The STL files are on Thingiverse. They're very nice, and they allow you to use the scope without at a dimmer setting, so it's easier on the tube. the tube on that is just huge. So getting the display that size, I would have loved to have seen the displays that size in the faster scopes, but physics limitations of the CRTs. But I really like the display on the 7603, and that's why I keep that one on the bench. Moving back up to the top of the bench, we have a PM100. This is my single-phase power analyzer. I have a custom cable that I've made for this that I hooked into the current limited supply for the Variac, so I can monitor exactly what's coming out of that supply. The PM100 is the last step after the isolation transformer and everything. It comes out. One of the things I like about the PM100 is it has its own separate power supply. I do have a Hoppy that does the same thing, but it doesn't kick on until you get about 80 volts. So if you don't have 80 volts going into the, this is the same thing that's true for the kilowatt. If you don't have about 80 volts going into the, coming out of the wall, it doesn't turn on. This has its own separate supply, and I get all the measurements that I need out of it. My Fluke 8840. This is a I believe, if I remember correctly, this is a 5.5 digit meter, so it's not the fanciest thing on the planet. The price was right when I bought it. The reason I keep it around is I use that one primarily now with my high voltage probe. Was my daily driver meter before I got the 6500. I have found using the 7510 to measure, because I don't want to put the high voltage in the 7510. I don't need 7 digits of resolution when I'm measuring kilovolts. The input resistor on the 20 volt range on this meter has the best accuracy for the voltage divider in the high voltage probe. So I keep that around so I don't get a skew in the measurements. And doesn't see a lot of use these days, but it still gets a spot on the bench. Agilent 53131A. This is my frequency counter. Bought this one used. I really need to get another display for it. The display is getting kind of dim and it could use a refresh. If anybody knows of an LCD or a non-VFD display for these, if anybody's got that project running, I'd be interested in trying that out, seeing what that looks like. But upgraded this one with the prescaler right there. And for frequency truth in the lab, this is it. But this is also backed up with my GPS DO. So the square wave output of my GPS DO, which is the Samsung unit that I referenced in a previous video, is the 10 megahertz for that unit. This particular one does not have the enhanced crystals or anything like that, so it is wildly inaccurate. Like it's for the amount of digits it has, it's pretty bad without the updated oven. But with the GPS DO, I get the accuracy I need. My next project, probably, depending on how the funds go, I'm looking at a Rubidium frequency standard for the lab. So what I'm thinking about doing, and if anybody has any ideas, let me know in the comments. I'm thinking about taking the GPS DO, programming that to having it do 1 pulse per second out, pumping the 1 pulse per second into the Rubidium frequency standard, but then having the Rubidium only update itself once a day. So at, say, midnight when I'm not in the lab, it does its frequency shift, so the GPS DO is not yanking the Rubidium around too much. So I'll be in holdover, but I'll only have a day's aging each time on the Rubidium. So that's what I'd like to do. I don't know if any unit will let me do that, but I get the accuracy, I get the self-updating accuracy of a GPS DO with the stability of a Rubidium, and that's my current thought process at the moment. I don't know if it will happen. Moving over to the middle of the bench, this is one of my original, I shouldn't say original, but one of my early meters that I needed. I needed some high-frequency AC stuff. And this particular multimeter, the price was right. The measurements are slow. At its highest accuracy, the measurements are almost a minute per reading. so it can be very slow. However, even on my 6500 and my 7510, they do AC up to a megahertz. I don't think they go to 10. This meter with the AC module, and I have the true RMS module in this one, this actually goes to 10 megahertz AC, which is rare in a DMM. So that's why this particular meter is still in the lab and on the bench. Is on occasion I need to do voltage measurements at 10 megahertz AC, and that's why he's here. This is a 6.5 digit multimeter. If I am remembering my specs correctly, it might be a 5.5. However, this particular unit, if you're looking at 10 volts, can give you one additional digit if you put in averaging and filtering and all of the tuning. He gives you one additional digit. Moving over to my two frequency standards, or not standards, but frequency function generators. These are exactly the same units, as you can tell if you look at this unit and this half of this unit, they're the same. This one sweeps, this one doesn't. So they go up to 2 megahertz. I am looking to upgrade those to some form of function generator, probably up to about 20 megahertz. But whatever I get is going to need to be able to go on the 10 megahertz reference in the lab. Moving down from there, we have a Type 106. This unit gets used a lot in the lab. When I'm working on scopes, when I need a square wave, things like that, this unit gets used a lot. I do get some questions as to why I use this unit during my calibrations when I could use the PG506. It's a drive. The tunnel diode pulsar that I have won't trigger off the PG506. It doesn't go to a full 100 volts. It tops out at about 62. This will do a 108 volt square wave, and it does it it does it pretty well until you ask it to go too fast. So it does it pretty clean. But that's why I have him here, and I use that a lot in my scope calibrations. This is a unit that is a very, very recent addition to the bench. This is my 2450 source measure unit. I'm planning on getting a lot of use out of this. Has some incredible specs and absolutely insane dynamic range. Videos will come that will have this being used significantly. This is one of my Keithley power supplies. I do have a couple more on the acquisition list. This one is the battery simulator. I've used it actually in the last video, the 600 subscriber video. It got used in battery simulation mode. It's also a nice power supply. I do want to get the 60 volt bench power supply from Keithley. I want to do some stuff with some buck converters and some boost converters, and the 60 volts there will be nice. I'm not sure exactly how that's going to work yet, but the 60 volt one is on the short acquisition list. But battery simulator for working on batteries, and yeah, that does 20 volts and 6 amps, so it's a good power supply. The Rigol Dp832a needs no introduction. I'm sure this is ubiquitous with a lot of people who take a look at the channel. Good power supply, not good for battery charging. If you're not exactly careful with this power supply, you can blow the front end up with it and send it into orbit. So do not charge batteries with this power supply. I have another power supply in the lab specifically for that reason. I think even, if I remember correctly, the video, I don't remember which one it is, but I think Dave Jones popped his front end on his as well. But I could be wrong. This is my 1010T. This is the power supply that I use for charging batteries. It's a grunty power supply. It doesn't care. I can abuse it. As long as I don't overdraw the current on it, it doesn't seem to care. I also needed a 100 volt power supply, which is odd to say, but I needed a 100 volt power supply to charge some batteries, because some of the UPSs that I work on, they have 70 volt and 100 volt battery packs. And also, the UPSs won't start unless they see battery voltage. So you got to hook up the power supply to the UPS to get it to kick over to see if it'll start. So I can do anything from 48 to, I can work on anything from 12 volt to 100 volt UPSs with this unit. Doesn't give me a lot of current, but when I'm charging 100 volt battery packs, I don't want a lot of current because I don't want it to go kind of nuts. So that's why the 1010T has a spot on the bench. Moving down, we have the Power Designs TP434B. I like the 434B better than the 434A for one reason. These ports are independent on the B. These two ports are a single port on the A, and you can't, and it's harder to use the supply separately. So one of the reasons why I keep that supply around is, one, it's a fantastic supply. It's very stable, but it also has positive negative rails for op amps. That supply with a adjustable up to 25 volts and a 5 volt supply, that supply lets me play with op amps very easily. Don't need to worry about too much, and it's just dial a voltage and off we go. Okay, for those that have been with the channel for a while, I kind of fell down a rabbit hole with curve tracers for a little while. So we have a, this is my 555 non-storage that I have on the bench. That is one of my two daily driver curve tracers. I have that one and the 576 that's over that way just a little bit, but I do have a curve tracer on the bench for my daily driver. It's I use that a lot actually, and I absolutely needed it to fix some of the other gear that's coming up. Okay, above the curve tracer we have some cleaning implements. I have a 284. It's uncaled, but it's working for what I need it to do. At the moment, that's why it's on the bench. I have done 2 of these in restoration videos now. This is my other amplifier checker, another SG502, the SG505 Mod 2, or Option 2, and the AA501 unit. This right here is probably going to change. I'm going to keep it. It's going to stay, but it's probably not going to live in this power frame. I'm probably going to repurpose this power frame for something else other than meters. This was my meter bank, and one of the reasons why I had to get the calibration equipment for meters is because I had to fix and cal all of those meters when I was working on the 576 and the 577. I was having some trouble with power supplies, and with some of these tech power supplies, with the way they cross-reference each other and things like that, it's real nice to be able to hook up a meter to every supply rail, hit the power button, and see what they all do. But getting a bunch of meters calibrated, because they actually, all of those were pretty far off. I believe I did a calibration video on one of those meters. If I didn't, anybody wants to see it, let me know. I'll make one. But that's what that's for. It's for just checking multi-rail supplies, just seeing, hey, yep, everything's there. The video previous to this one was a soldering video, so I'm going to hit this quickly. I do have some more stuff coming, should be here this week. I have another base coming, and I did buy, finally, one of the versions of Hot Tweezers. I ended up with a whole bunch of boards that I need to pull some parts off of that were pretty beefy, and so the Hot Tweezers made sense. So I do have a bit more soldering stuff coming. If anybody would like to see that, let me know in the comments, and I will do some more soldering videos. The desoldering tool is an FR410. Absolutely fantastic desoldering tool. As with all desoldering tools, it does require maintenance, filter changes, filter cleanings, things like that, but fantastic desoldering iron. And then this is the nitrogen iron, and I got, I have a base coming for the standard iron, so I'm going to have that hooked up again as well. Towards the floor on this side of the bench, we have a Fluke 434, or no, sorry, a 433A DC voltage calibrator. So we have DC, volts up to 1,000 volts, and then we also have AC volts up to 100 volts. With the this is a 5200A, this is a 5205A. This is the associated amplifier that talks to this guy, and this goes to 100 volts. That goes to 1500 volts. These and a couple of resistor substitution boxes are what I use for calibrating meters and doing some voltage checks and things like that. Again, on the channel, needs no introduction, a 576. I don't know if you can see it. There's a second 576 hiding back there that's restored as well. But that's got, that's the 576 that I use on the bench as the daily driver. And I needed the 576 to fix the 5200A. There's a rebuild video on the channel on that one as to what I had to do to rebuild the negative 190 volt supply. Going up, we have the distribution box for the 10 megahertz reference, which brings the 10 megahertz reference into the rack or into the shelving unit. This spectrum analyzer is going to move to the bench. I have some spectrum analyzer work that I need to do, and he's going to be my daily driver for that. This is my spectrum analyzer with training wheels. If you're new to spectrum analyzers, see if you can find a 4411B. It's not the fastest spectrum analyzer in the world. It only goes up to 1.5 gigahertz. However, on the input, this is rare. This can tolerate 100 volts on the input. So if you're 100 volts DC, so it's really hard to blow the input on this. Well, spectrum analyzer wise, it's hard to blow the input on it. However, so this is far more tolerant of technician mistakes than my other spectrum analyzer, which is right there. So that's why I'm going to put him on the bench. Also, he has it's got an LCD in it, so I'm not burning time on the LCD. I am just working with the analyzer. This particular example has the tracking generator. I have found that to be a somewhat useful feature, but it is not necessary for a spectrum analyzer, but it is definitely a nice to have. Moving over and up. 20 megahertz sweeping function generator, just a cheap BK one. Does okay, not very frequency stable, so I tried to use it as my 10 megahertz, but that didn't work. When I was fixing that TG501, it was just not stable enough. So, but it does sweeps. That's the one I'm looking at maybe replacing with a more modern unit. My HP 8596. These two spectrum analyzers came in at the same time. The 8596, it's an older unit, but it was the specifications for this particular unit with all the modifications and all the upgrades that it had with it, it was a deal that I couldn't pass up. You'll notice this large proboscis kind of sticking out of it. This one is completely intolerant of DC on the input because it goes up to 12.6 gigahertz or 12.8. So this is a 24 gigahertz DC blocking capacitor, and I have the inputs terminated so they don't pick up any stray static or any signals in the lab because my environment's kind of noisy. This is my 8657A signal generator. We cover 100 kilohertz to just over gigahertz with it. It is an RF signal generator, so the maximum it outputs is 2 volts unterminated, 1 volt into 50 ohms. But it also has a very precise amplitude output, and it has a very stable clock, plus a 10 megahertz reference, so it's hooked up to the GPS DO as well. So are the two spectrum analyzers. It was what I used to tune the receivers and things like that. If one thing to note with the A version is, I believe it is the A version that has the electronic attenuators. It doesn't have electromechanical attenuators. So just something to know if you're looking for one of these generators is some of these outputs have mechanical attenuators that do go bad over use. Moving down to my slower spectrum analyzer. This particular spectrum analyzer only goes to 40 megahertz. However, it is unique in the fact that it has a 50, 75, and 1 megohm input. That the 75, usually you don't find all three on a spectrum analyzer, but the fact that it can do all three and it can go up to 40 megahertz, this is a nice go-to unit for the slow side if I don't need to do anything if I don't need to do anything over 40 megahertz, because that's all it does. But yeah, anything in the low end, audio, things like that, that is fantastic. One of the monsters. This is the DSA. I did a video on this unit specifically. This is my 1 gigahertz sampling scope. This is the fastest scope that I currently have in the lab, but I'm looking at getting a little... Actually, no, I take that back. It's not the fastest scope that I have in the lab, but it's the fastest general use scope that I have in the lab. But I am looking at getting... seeing what we can make that guy do when we hook it to a computer and getting some GPIB working. Other than that, I've needed it to do some of the 1 nanosecond time mark checks and things like that because I've needed 1 gigahertz capability, and none of my other scopes in the lab do it. But the 11A72 is a dual 1 gigahertz plug-in. If you equip this correctly with 11A34s, these are 400 megahertz plug-ins. You can get 12 channels of 400 megahertz or 6 channels of 1 gigahertz. We also have a 7A33, which was recommended to me by a viewer. Thank you for that. The nice thing about the 7A33 is it can do a 10 gigohm input impedance on the differential amplifier. So I will get probably a couple more 11A72s. Not really sure if I need any more of the 11A34s, but 12-channel scope, which is kind of nuts. I did a recent video on this guy. This is my 11801C. This is the one that got damaged in shipping, but I've got it repaired and the front looks decent. This is my one functioning module. I am going to test the doing the calibration on the other 2 modules if I can get the equipment. That way I can just confirm that hopefully it might be a corrupted VRAM is why I can't talk to them, but we'll have to see. But that is what I've got. I would love to fill out these other 3 bays with modules, but their cost has gone kind of nuts at the moment. This is the 3D printer in the lab. It's a small one, not really too huge. Here's a sampling module for a tech scope to give you an idea how big that is. It's not overly large. It's a Cetus Mark III extended, so this is even the bigger version. This is the extended version. The other version doesn't come down that far. It comes down about here. But that's what we use for 3D printing. Sometimes gets interesting with the cat. She likes to bat at the 3D printer when it's moving, so we have to persuade her not to do that. But anytime I need to make small parts for restoration, like those plastic pieces for the PG508, this is what they come off of. This particular printer, the reason I went with it is because it has linear rails. So this has full, true linear rails on the 3D printer, not just bearing supports. So it's a very accurate 3D printer. I wish they made it a little bit bigger, but for what it is, it's perfect. This is my main PCB building computer, editing computer, and workstation for the lab. To give a size comparison, the center monitor is 43 inches. The 2 on the side are 24, but they're mounted vertically. The center monitor is 4K. The 2 on the sides are just 1080 monitors. Again, looking at schematics, especially on the big 4K monitor, is fantastic. It actually brings some detail out of some of the older scans and things like that, and allows me to get a little bit deeper into the schematics and go from there. Also, when I'm designing a PCB, having a monitor this big does help. It lets me zoom out and get a big picture view, zoom in, get an in-depth view. So it is nice to have. It's nothing special in terms of monitor specs. It's not overly fast. Actually, it has some pretty horrific ghosting when you go from a bright white page to a gray or dark theme page. Its main purpose was 4K. I had two, and I was running dual 4K monitors, and it was too much. It was too big. Having to look side to side and to use the extreme edges of the monitors, having the split in the middle. I would not recommend two 40-inch monitors. However, this is my current monitor setup, and I find for PCB design and CAD and editing work, this to be a very, very beneficial setup. That's what I'm currently using. The machine that runs this, I actually did a video on. It's the HEDT machine. This thing just annihilates video. It is absolutely fantastic. It's rendering and doing stuff in Fusion and things like that too. It is it just crushes compute. So to render out this video is on the long side. Well, my wife streams, and she does 2.5-hour streams, 3-hour streams. It chews through 3 hours of video in 12.5 minutes. It takes me longer to shoot the video up to YouTube than it does for this machine to render it out. It just cranks through it, which is absolutely incredible for video editing, because that's where a lot of the time is, especially if there's not enough horsepower. But yeah, it makes videos not be an overnight thing. One other thing that I want to talk about is I mentioned some Canon glass that I already had. I have this guy. That is my Canon T3i. That's what I take all the board photos that I put on Patreon. One of the things that I do release to the patrons is if I take a bunch of tech photos of pre and while I'm working and things like that. They're just the photos. I post those up on Patreon, and I also post the videos as soon as they're edited. So I'm trying to keep, barring shipping delays and weirdness and things like that, I am trying to keep a once a week video release for Friday. So typically that means I will release it late Thursday evening. I do post the videos as soon as they're edited. They go up to YouTube, and I release them on Patreon. So patrons do get early access to some of the videos, and if there is currently no backlog of videos. There's not like, oh, sign up for Patreon and there's sign up as a patron and there's 100 videos to watch. Nah, it's there's nothing like that out there. We are running. Actually, this video will only put me 2 videos ahead. Actually, technically 1 week ahead. But that's the still camera I use. I take a lot of my tech photos with that. That's really it. There's a lot of back-end support. I've even created a playlist on the channel called Lab Drudgery that is just the stuff, the minutia it takes to keep a lab up and kicking. So there's a lot of that out there, things like that. So that's why Canon glass. I want to stick with Canon glass because I've got this Canon camera, which has been good for me so far. Plus I have that, and I have multiple lenses for that already. So that's one of the reasons I want to stick to Canon glass when I do 4K. And this computer can handle the 4K editing. That will not be a problem. It can chew through 4K without too much trouble. And back where it all started. Thanks again for joining me in the lab for the lab tour. I know I rambled quite a bit in this video. If you guys have any suggestions, comments, ideas for videos, stuff you'd like to see, want to say hi, let me know. Leave it in the comments below. I do read all the comments, and I am getting some great video ideas in the comments. There is some deep dives coming. Like one of the videos I have planned is a deep dive into capacitors, and I'm gonna limit that one strictly to electrolytic capacitors, because picking filter caps and things like that, and replacing that. But I've also gotten some requests to get into some of the different parameters of capacitors as well. So we'll go down. We will dive down that rabbit hole head first and see what we can make clear as mud. Once again, thank you everyone for being here. This channel would not exist without you guys here. And I greatly appreciate everyone being here and all the comments and everything that people have been sending me over the last year. If you guys like this type of video, let me know. And if you want me to do a annual recap of just what's changed through the year, things like that, I can do that too. I'd probably set that as a December-ish time frame, just what's changed in the lab and YouTube land. So as always, let me know, and I will see everybody in the comments section and in the next video. Bye for now.